Hello everyone, this is RVD and welcome to yet another video of my playlist Placement Interview Questions on C Programming. Fine, so without further delay, maybe only I'll remind you to subscribe. I hope all of you have already subscribed, but if not, you can very well subscribe my channel. You can see the subscribe button right down there, and I sincerely request you to share with all your acquaintance so that I'll be able to reach to more significant audience. Fine, so let's continue with the current video, and the question for today's video is, what are the bitwise shift operators in C? Fine, if you remember in the previous video we have already talked about the bitwise operators, okay, and we know that bitwise operators are the operators which work on the bit pattern. Fine, so there we had seen the basic bitwise operators like AND, OR, XOR and complement. In this video, we'll see the remaining set of bitwise operators. They are nothing but called as bitwise shift operators. Fine, so as the name suggests, your bitwise shift operators are also used to perform shifting on binary patterns. Okay, obviously, bitwise operators, they also work on binary pattern, but here the operation that we perform is different. It is obviously used for shifting operations. Okay, they are used with integer operands, correct, because the integer operands that we will be having would be converted to the corresponding bit pattern, and then that bit pattern is used to get operated. Fine. So they work on the bit pattern of the operands. That's what I said. So we need integer operands. It will be converted to bit pattern. The bitwise shift operators will work on the bit pattern of the operand, and then finally whatever result will be produced, which will be in the bit patterns, will be converted finally back to the integer. So the final result that will be produced will be of integer type. Now what are the bitwise shift operators we have? There are two bitwise shift operators we will be having. That is bitwise shift left and bitwise shift right. Okay, is that clear? So that's the basic concept of, or rather the types of bitwise shift operators. Now how exactly they will be used? You obviously have seen the symbols. This is the symbol here. Now the operation we will be looking at, okay, as an example. This is bitwise shift left and this is bitwise shift right. Okay, let's look at the operations. So the first example that we are going for is bitwise shift left. So let us take an integer a, which is 13, and this is what we are doing. What is this called? A is equal to a left shift by 1. Okay, so if at all you see the broad aspect of it, how do we use the left shift operator? So what is this? This is nothing but the operand. That is whom to shift. So किसको shift करना है अपने को? We have to shift what? We have to shift a. Correct? कितने से shift करना है? So this is nothing but number of shifts. So we have to shift the corresponding operand by 1 bit. Fine. So first I'll show you how exactly it gets executed, or rather it gets shifted, and then we'll see the result here. We can also see the execution. Not a problem. Okay, but see, now currently we have our a as 13, and this is what we have done. A is equal to a left shift by 1. So what is 13? You know, 1 1 0 1, that is 13. Let us do the conversion into 8-bit, okay, and we'll put it like this. Now I want to shift the complete pattern to the left by 1 bit. So we are going to obviously punch it from the right. So this 0 is going to fall down. So 0 has fallen down. Can you see there is an extra space created, and that will be padded by 0. And that's how it will get shifted by 1 bit to left. Now what is this value? You can see 16 plus 8, 24, plus 2, 26. So obviously the final value of a that we get is 26. If I roughly show you, let's say we have 26 now, right? If I again do left shift by 1, this 0 is going to fall down again. There will be a space here for one more 0. So it's going to be what? 32 plus 16, 48 plus 4. 32 plus 16, 48 plus 4 is 52. So A is going to be 52. So can you see one times when you are shifting by 1 bit, it is getting multiplied by 2. Again 1 bit shift, it is multiplied by 2. So if I shift by 1 bit, it is multiplied by 2. If I shift by 2 bit, it is multiplied by what? 2 raised to 2. So if I shift it by k bits, it will be multiplied by 2 raised to k. But all these things is when you do shift left. I hope you understood the whole the working that I've shown you, and you will see the similar answer over here. So let's go ahead. So when I do this, A shifted by 1 to left, I get answer 26. We have even gone ahead and we have done, if I shift one more time, we get the answer 52. So what's the conclusion we can draw? Shifting 1 bit to left is multiplied by 2 raised to 1. So we go with that particular concept and we make it generic. Then shifting k bits to left is multiplied by 2 raised to k. Clear? I'll show you that as an execution also. Okay. But currently let's move on to the next example, and that is shift right. Okay. So I've taken one number, let's say 37, and I'm shifting 1 bit to right. I guess all of you might have now understood what exactly it's going to do, but let's still do the checking. So now I'm doing it for 37. So A is 37, and what I want to do is A equal to A right shift by 1. Now what is 37? 32 plus 5. Is it 37? 32 plus 8, 40. 32 plus, I made a mistake. Yeah. So this is 1, 2, 4, 8, 16, 32. 32 plus 4, which is 36, and 1, 37. And let us make it 8 bit. Now what I want right shift by 1. So I have to punch from left. So this 1 is going to fall down, correct? And there will be a space here. Obviously you should pad it by 0. Clear? Now, if I do that, see what it does. 1, 2, 4, 8, 16. 16 plus 2, 18. Okay, that's it. So what's the value of A? 18. And you remember the integer division. What is 37 divided by 2? 18. Integer division I said. Okay, let's try one more time. Let us have 18 now. 0, 0, 0, 1, 0, 0, 1, 0. That's 18 we have. So let us shift one more time to right by 1 bit. So this 0 falls down, and we've got one more 0 here. Now when I do that, okay, see what happens. 1, 2, 4, 8. 8 plus 1, 9. Again you can see 37 became 18, so that is divided by 2. Again 9 divided by 2. So we are getting the similar conclusion. If I shift by 1 bit, it is divided by 2. 2 bit, then it is divided by 2 raised to 2. So if I shift by k bits, it's going to be divided by 2 raised to k. And obviously not very surprising, it is quite opposite to the shift left concept. So shift left, it's going to obviously multiply, and shift right is going to divide. Now how do you remember this? I'll tell you a simple trick. See, when you do this 32, 16, 8, 4, 2, 1. So now try to understand, when I go from right to left, so when I'm shifting on the left side, am I getting the double values or what? Is it getting multiplied or is it getting divided? You can see it's getting multiplied. 2, then 4, then 8, then 16. So when you do shift left, it bound to multiply. And when you do shift right, it bound to divide, because that's how it happens. And you know, 1 bit is getting shifted on this side. You can clearly see 32 becomes 16 if 1 bit is shifted. So that's the logic. Let's get back to the slide and we'll be able to understand this properly. Okay, so you can see we got 19 here. That is because, I guess, one second. So I made a mistake. Yes, very rightly. 16 plus 2, 18 plus 32 plus 4, 16 plus 1, yeah, it has to be 18 and not 19. Clear? We'll even check it with the execution, so you can pardon me for this. It has to be 18. And we had further seen that when we divide this by 2, we get what? We get 9. Okay, so see what exactly is the conclusion. Shifting 1 bit to right is divided by 2 raised to 1. Shifting k bits to right is divided by 2 raised to k. Fine. Now we're going to show the execution. So that will make the things very clear. Okay. So now suppose let us have what we have had earlier, 26. So 13 rather, we start with 13 left shift by 1, and let's see what's the answer. See, 13 left shift by 1 is 26. So if I left shift by 2, okay, let's see what's the answer. It is 52. Yeah, now let us do the one which we had a correction with. So 37 right shift by 1. Let's see what we get. Yes, it is 18. Okay, so I hope you understand, it is not 19, it has to be 18. And if I left shift it by 2, then it has to be 9. Is that clear? So this particular mistake I already rectified, and I had proved it with the execution as well. Okay, so you're supposed to read it 18 and not 19. And we also understood how the shifting left results into multiply, and shifting right results into divide. Okay, so that is regarding bitwise shift operators. We can even try applying it on negative numbers also. Okay, that exercise I leave it to you. You can even put the comments in the chat box regarding how do we implement, or how do we rather go about negative numbers and do bitwise shift left, bitwise shift right. Okay, which one rather will have some sort of effect or some sort of difference. I would like to get comments on that in the chat box. Okay, so that was about bitwise shift operators. So summarizing, two types of bitwise shift operators: shift left, shift right. Shift left results into multiplication, shift right results into division. Okay, so that was the current video about bitwise shift operators. That's it from my side. Thank you and happy learning.